So, welcome friends. Today's topic is significance of fabric properties in design. I hope most of you have already studied fabric production techniques and the properties of the fabric also. We will now see how the different fabric properties are relevant from the design point of view. Now, here the very first slide gives you an idea about the way the fabrics can be classified. According to structure, it can be classified as woven fabrics, knitted fabrics, braided fabrics, non-woven fabrics and a combination. So, you can have 1, 2, 3, 4, 5 types of fabrics. Then in non-woven, we can have biaxial and triaxial. In knitted, we can have warp knitted and web knitted. Braided, we can have tubular braid or flat braid. Non-woven, we can have bonded and felted type, and in combinations we can have stitched, bonded, laminated. So, therefore, the fabrics are also too many in front of us, and whenever we think of a specific product, we will also, the question that will come to our mind is which fabric to be chosen, and hence we need to know little details about the properties of these fabrics, so that our selection criteria or our selection process does not go wrong. Here is another classification based on dimensions. We have 2D fabrics, we have 3D fabrics and we have 2.5D fabrics. 2D fabrics: woven, knitted, braided, non-woven. 3D fabrics could be again woven, knitted, braided, non-woven, and 2.5D fabrics as an example could be carpet, towel, these are called 2.5D. So, these are the two ways in which fabrics are classified. Now, what are the basic parameters of a fabric? For woven fabric, first important parameter is the material. It is made of which material? Is it cotton or polyester or rayon or silk or wool? So, material is one of the important parameter. Then comes type of weave. What is the type of weave that has been used to make the fabrics? Then what is the thread density? What is that is EPI, ends per inch and picks per inch. What is the fabric weight, that is, or areal density expressed in terms of GSM, that is gram per square meter. What is the fabric width, then thickness, crimp, cover factor, these are all basically fabric parameters. So, whenever design comes, we have to actually give the details, that is, this fabric should be made from this material, this should be type of weave, this should be EPI, PPI, this is the GSM that we need, and this kind of thickness is required, this should be the cover factor. So, these are all part of the detailed design. For knitted fabric, similarly, material, type of construction, fabric weight, that is areal density, width, thickness, stitch length, stitch density, tightness factor. And for non-woven fabrics, it is again material, fabric weight, fabric width, thickness, porosity. So, typically these are the fabric parameters. From there we move on to the next slide, just to understand very basics of characteristics of woven fabrics. So, we have woven fabrics, we have knitted fabrics, then we have braided fabrics, we have non-woven fabrics, and we may have compound fabrics also. So, let us look at the woven fabrics. We are all familiar with woven fabrics. Okay. Now, there is a picture on the right hand side. It is very clear that this is a plain woven fabric. Now, generally in the woven fabrics, the yarns are orthogonal to each other. We have two set of yarns, so we all know that. These fabrics are very strong generally. Woven fabrics are strong fabrics, then they have high initial modulus, tensile modulus generally more than shear modulus. They are less stretchable, they are less deformable, they are dimensionally stable, and generally they have a smooth plane surface, and the fabrics are durable. This is all in comparison to the other mode of fabric productions, that is in comparison to knitted fabrics or non-woven fabrics. From there we go little details about the woven fabrics now. Now, in this table what we find that there are different types of weave, and you are all familiar with that we have so many types of interlacement patterns, and we create different type of fabric architecture. It all depends the way the two set of threads are interlacing each other. So, we have plain weave one by one, that is one up one down, we all know. Interlacing patterns, warps are interlacing the weft yarns. General character of the fabrics are stated in the here. Maximum number of interlacement you will find in the plain woven fabrics. It has a higher shear rigidity, strong and stable structure, balanced or it could be unbalanced. It wrinkles most. It is sleazy. If set is low, it is less absorbent with respect to liquid absorption. Typical example is voile, sari, shirting, it could be dhoti, and there are many more where plain woven fabrics are used. Then comes basket weave, and we have so many types of basket weaves. The typical diagram is given here. Here two or more yarns in either warp or weft or both could be there, and they are woven as one in a plain weave pattern. So, the interlacement pattern is basically plain weave. The structure characteristics is balanced, interlacement pattern is less in comparison to plain weave, then the interlacement pattern is basically plain weave pattern. It looks flat, it is more absorbent, it wrinkles less, it is good drapability, and it has a greater resistance to tearing. Sometimes we may need a fabric which will give us better tearing resistance, and in that case a basket weave is better than a plain weave. So, these are used in suits, sailcloths, shirtings. These are the typical applications, and then may be many more. Then comes twill weave, you are also familiar with. Warp or weft yarns float over two or more yarns from the opposite directions in a regular progression to the right or left. So, we have 2 by 1 twill, 2 by 2 twill, 3 by 1 twill, like that, and what we create a diagonal lines. You see here in the diagram we are creating diagonal lines like this. Fewer interlacement patterns in this case, it wrinkles less, is strong and firm structures, more pliable, can have higher set, and it is durable also. Typical products are denim, gabardine, herringbone, suits, coats, these are typical applications. Then comes satin weave, it can have warp and weft yarns, they float over 4 or more yarns from the opposite directions. See here we have, if you see the image, we see that long floats are there. That means the total number of interlacement patterns or interlacements per unit area will be much less in this case. So, it generally creates a flat surface because it has long floats. In this diagram, it shows long webbed floats. So, surface being flat, it is very lustrous. The fabric is smooth, can have very high set also, and long floats leading to possibility of slippage and snagging. That is the negative point you can say of this particular type of fabrics, but it gives a luxurious appeal and is generally used for making upholstery. So, these are the typical type of weave which are used. The other weave is a honeycomb weave. Honeycomb weave characteristics is it resembles cellular structure of bees honeycomb. A typical diagram is shown here. Is a little 3-dimensional effect is there in this honeycomb weave. It can trap air and generally is used for making blankets or towel. Then comes triaxial fabrics. So, previously whatever we have discussed, they are all biaxial. So, we have two set of yarns, we call them warp and webbed. Now, here we have 3 set of yarns, and this is how the yarns are. If you look at this diagram, we have blue yarns, there are green yarns, and then there are some yarns which are little reddish in color. You can say brown color type of yarn. So, these are the 3 sets of yarns which are there. Are 2 set of warp yarns are inserted at 60 degrees to the webbed, and in Triaxial fabrics 4 sets of yarns are inclined at 45 degree to each other. That is also there. So, these 3 sets of yarn form equilateral triangles, and the fabric is open with diamond shape at the center. If you look at the holes that we see here, they have a, you can see how many types these holes are. Looks like a 1, 2, 3, 4, 5. This looks like a, let's say, hexagon type of holes which are created between the yarns. So, that is the triaxial fabrics for us, and the fabrics are stronger than rectangular woven fabrics. The advantage that we get, that is its tear and bursting resistance, is superior to plain woven fabrics. So, if you want to resist tear, so where the fabric is likely to fail because of tear, this is the right weave that we have to use. So, for many technical products, triaxial fabrics are very much in use. Shear resistance is also very high because intersections are locked. At every intersection, there are 3 yarns are passing over each other. So, every intersection gets locked. So, it is difficult to shear. That is the another interesting property of the triaxial fabrics, and they are used where? They are used in sailcloth, tire fabrics, balloon fabrics, and other laminated structures which are used for different types of technical applications. From there we go to the next slide. Here there is a comparison of cover factor and their adjustment. So, plain weave, if the cover factor is plain weave, let us say if it is considered to be 1, the cover factor, then 2 by 2 weft rib will be 0.92 times of whatever was the value for plain weave. 1 upon 2 or 2 upon 1 twills will be 0.87. The adjustment factor is going to be 0.87. For 2 by 2 mat is going to be 0.82, and for these twills, that is 1 upon 3, 3 upon 1 is going to 0.77. For sateen it is going to be 0.69. So, if cover factor of a plain weave is whatever, this is 1, the adjusted cover factors for the reeb, twill, mat weaves are stated here. We have to multiply them by this factors to get the maybe typical cover factor of these fabrics, provided other parameters are same. So, this gives a little bit of tightness that we can expect in a fabric. So, you can say the plain weave fabrics will be very tight. The others, whether it is twill or reeb or mat or sateen, their tightness factor is going to reduce, they will be less and less tight. Typical characteristics of fabrics are shown here. This may be different also, but some typical values are given here to give an idea. Width of a fabric can be from 91 to 406 centimeter, that is, it could be almost 0.1 meter to almost 4 meter roughly, you can say that could be the width for normal fabrics. And also we can have fabrics where the width is little less, that is almost 0.9 to 1.5 meter, that is mostly available commercially. This is the type of fabric which are available. Then width of narrow fabric is around 30.5 centimeter. So, we have fabrics which are commercially available, 3 different width, 30.5 centimeter, or it could be 91 to 152 centimeter, or it could be 91 to 406 centimeter. These are typically available. Fabric weight or aerial densities, for lightweight fabric it is 68 to 102 grams per meter square, for heavy fabric it is 173 to 242 gram per meter square. Cover factor details are given here actually, that is total cover factor may typically anything between 23 to 26, warp cover factor 20 to 22, weight cover factor maybe 12 to 16. So, that is the range in which cover factors of normal fabrics will lie, and the cream value is also may vary from fabric to fabric, but to get an idea the warp cream is could be anything between 2 to 6% and the weft cream could be 6 to 8%. These are some typical values. It may differ also depending upon the type of fabric or type of yarn that has been used to make those fabrics. So, to just get an idea that what are the typical characteristics of the fabric, some values are quoted here. Then here there is a qualitative comparison between certain fabric parameters with the different types of fabric construction that we have seen just now. We can have plain woven fabric, twill woven fabric, satin fabric, basket weave woven, and lino is another type of weave which I have not discussed, but this is another type of weave which could be there. And if I compare the stability of these fabrics in terms of drape or porosity or smoothness, balance, symmetrical or not, whether crimp is low or not, then the qualitative comparative comparisons is given here, where A stands for average, G stands for good, E stands for excellent, and VP stands for very poor. So, like take any let us take the value of stability. Structurally, which one is very stable? Plain weave woven fabrics is very stable, they do not distort much. Lino is also very stable, they do not distort. The yarns are basically held in position in lino weave, so they do not move much. where twill is average in terms of stability, structural stability, and satin and basket, these woven fabrics, the stability of the yarns within the structure is less. That is, they can easily move, and therefore, the structure can get distorted easily. That is what stability means. Such kind of comparative statements about the properties of fabrics can help the designer in choosing which type of weave he or she has to select for a given applications. So, depending upon the nature of the application, we have to decide when you go for detailed designing that which type of weave we should choose. So, keeping in mind the various properties of the fabrics in terms of stability, drape, porosity, balance, symmetricity or crimp, we can decide which particular weave we should choose. So, this side is basically we can say parameters or characteristics of the fabric, and these are a relative assessment about these different types of weaves which are there. Now, after woven fabrics, we go to the another type of fabrics called, we know them, the knitted fabrics. We are all familiar with knitted fabrics. We have weft knit and we have warp knitted fabrics, and the two diagrams are shown here, weft knits and warp knits. In weft knits, the loops of one row of fabric is made from the same yarn. Some structures are known as plain, reeve, interlock, purl, like that. So, one row is made from the same yarn, like this row as shown by the dock line, they are made from the one yarn. So, one veil is made from one particular yarn, the next row is made from another yarn. So, every row is representing a yarn from a specific cone. The neighboring rows are made from the yarns from other cones. In the warp knit, in comparison to weft knit, the warp knits, each loop is made from different warp yarn. Each loop is made from different warp yarns. Neighboring loops of one course is made from the same yarn. That is how you can see the yarn path is shown here. This is made from one yarn. So, these loops vertically, if you look at it, they are made from one particular type of yarn. Here the horizontal direction, the yarn is moving and it is coming from one particular cone. So, this is how the two types of fabrics are there, knitted fabrics, and both warp knit and weft knits. And in the case of warp knit, there could be two types, tricot and rassle, depending upon the type of machine that is used to produce them. Now, typical characteristics you need to know. Warp knitted fabrics, these are multi-layered and generally fall between woven and weft knitted fabrics. Warp knitted fabrics with laid in yarns are similar to woven fabrics in their mechanical properties. Weft knitted fabrics, yarns are looped around each other. Knitted fabrics are more isotropic than woven fabrics. Tensile, shear and bending moduli are all of same order. These are very low modulus. So, initial modulus of the fabric is very low, it can extend easily. Fabrics are generally weak in nature, it is stretchable fabrics we can produce, and loops can easily deform. It does not need any ironing, there is the advantage. So, some products where ironing is not required at all, we generally go for knitting. Then it has a very soft handle. You see, all interior or inner garments are made from knitted products, because the loops can deform easily, and therefore, they are generally fabrics as a whole become very soft. It is compressible. So, that is the advantage of weft knitted fabrics. Vis-a-vis on the left hand side we see the warp knitted fabrics. So, if we go for a comparison of weft knitted structure, because then within weft knitting also there are many structures. We have plain, reeve, purl, interlock. These are the 4 structures which has been taken for as a for comparison, because if we decide that we have to go for a knitted fabric, the immediate question will come, which type of structure we should choose, or which one will particularly suit a specific application, or we want to whatever we were trying to design for that particular design, which particular type of knitted structure will be the best. And therefore, some comparative statement about the different type of structures and their characteristics will be very helpful. So, appearance wise the comparisons are given here. Difference on face and back, V shape on face and arc on back. This is typically appearance wise. Reeve same on both sides, purl same on both sides, interlock same on both sides. So, interlock, purl and reeve fabrics will look exactly similar whether I see the face side or back side, whereas the plain of fabrics will look different in the face and the back side. Extension wise, you see purl gives you very high extension. So, if high extension is required, purl structure is the best, whereas the other structures gives you moderate extension, lengthwise directions, and in widthwise directions purl will give you very high extension. So, purl gives you high extension both in the lengthwise and widthwise directions, whereas plain will give you high extension 30 to 50% in widthwise directions, much higher in the case of reeve, and interlock it is just moderate. Therefore, depending upon the type of extension we required, we can choose a particular type of structure. And area wise then extensions are given here. So, where very high extensions are required, in some products we can go for purl. An example maybe let us say sportsman's product, any uniform that you want to make, which is is basically skin tight of garments. For sportsmen with high activity sports, there are a lot of running around, a lot of movement, and therefore, a stretchable fabric is very much desired there. So, a purl type of structure may help. The other comparisons are in terms of thickness and warmth, unroving capability, curling tendency, end use. Some end use are also stated here. So, you can see that thickness wise also someone looks much thicker, and thicker the fabric warmer it will be. So, some thick fabrics are always warmer. So, interlock is thicker, purl is thicker, plain is also thicker, reeve is much thicker than the others. So, here these comparisons of the various properties is going to help us in choosing the right type of fabric. So, if you look at the use of weft knit, typically the apparel use are sweaters, t-shirts, golf shirts, sweat and exercise shoes, figure hanging garments. So, these are the typical apparel use. Medical applications are also listed here, technical applications also given here. Property wise they are easy care, resilient, soft, warm, in still air environment allows freedom of the body movement. In still air it is warm, otherwise any knitted structure is quite porous, and therefore, if wind is blowing, then the wind can easily penetrate. So, therefore, in still air it is very warm, but if the air is not still, but moving, in that case the cold air can easily penetrate the structure and can go inside the can go near to the skin. In the warp net, as already discussed, or that there could be two types, trichord and racial. There are two types of warp knitted fabrics which are available, and they are also used depending upon the type of machines. These names have been given. Characteristics are trichord, fine vertical wales on the surface and crosswise ribs on the back. Racial gives you less like open constructions with heavy textured yarns held in place by finer yarns. Typical structures are shown here for racial, and this is for trichord. The use is for outwear, underwear, blouses, bed sheets, pillow. These are the various types of use of trichord, and the other one is racial. That design is also shown here, and it is used for carpets, fine delicate laces. The racial type of warp knitting machines are used. So, this is how the fabrics will differ from each other. So, what is the difference between woven and knitted fabrics if you now compare? Firmness wise, woven fabrics is always much more firmer. Knitted fabrics are not firm. Stretchability, woven fabrics are not stretchable unless we insert some elastic yarn, otherwise woven fabrics will not be very stretchable. If the yarns are stretchable, that is if we use lycra yarns while making the fabric, then it is different. Otherwise, stretchability of woven construction will be always less than knitted constructions. Drape wise, it is poor than knits, where knitted products are better in terms of drape. Abrasion resistance, abrasion resistance of knitted fabrics are certainly better than woven fabrics, because the fabrics are mobile in nature. Now, as we abrade by a brader, the yarns can easily move, and thereby it can reduce the stress that is generated by the abrader. And because of that mobility which is there in the knitted structure, the abrasion resistance of the knitted fabrics will be expected to be better, provided the yarns are exactly similar in nature. Snagging tendency for woven fabrics is always much less. Here knitted fabrics shows the snagging tendency is more because the structure is loose. Therefore, snag resistance is poor. Peeling less than knits in woven. Knitted fabrics can peel very easily. Why? Because generally in the yarns we put less amount of twist, and therefore, the fibers from the surface of the yarns or fabric surface can easily come out, and then they can get entangled, and once they get entangled, the surface fibers, they form peels. So, peeling in open fabrics will be less, because the yarn gets support at numerous interlacement points. So, the tendency of a fiber to move out from the body of the yarn will be much less. Thermal insulation, knitted fabrics will give you better insulations, because the knitted loops are 3-dimensional in nature, and the fabric thickness is always much more. That is why knitted fabrics are better in terms of thermal insulations. So, these are the comparisons between the two types of fabrics. The lino weave, as we were discussing about lino. Now, in this particular slide, we see the way the image gives an idea about the way the yarns are interlacing each other, and you look at the structure. Now, these yarns you see that going like this. So, this pair of yarns is actually holding this yarn between them. This webbed yarn is actually held in position by the two lino yarns, and therefore, it is not going to move easily. So, linos adjoining warp ends do not remain parallel when they interlaced with web, but cross each other. So, this is where it is crossing each other, these two yarns are crossing each other, and therefore, the webbed yarn remains trapped, and hence they can't move. They are with relative to each other, they will not. So, relative movement of the webbed yarns will be almost frozen. They will not be able to move, because they are gripped by the warp yarns, and since these two yarns are crossing each other. These are used to produce open structure. When you need to produce very open structure as shown it here, if we make the structure from normal plain weave fabrics, then we find the warp and webbed yarns are actually moving relative to each other, and the structure as a whole is not stable. But many a times we need a stable structure, but at the same time the structure has to be stable also. Sorry, we need an open structure, and the structure has to be stable as well. Now, if we want to open structure and stability, then lino is the answer. And there are instances, especially in technical applications, where such kind of structures are required. Stable open structure is required, and there lino weave will be of great advantage. Other fabric types are just felted fabrics are there. Through milling and brushing during finishing with combination of heat, pressure and friction, thick dense fabrics will give you a felted appearance. So, dense fabric with felted appearance is produced that do not fray easily. Generally, they are produced from wool fibers. Second, felt because the wool fibers have scales. So, normal woolen fabric, maybe to be a plain weave fabric or 12 weave fabric or maybe satin weave fabric, whatever fabric we produce, then those woolen fabrics are now felted by this process, and we create such kind of structures where once it is felted, we will not be able to make it out whether it is made from originally it was in a plain open fabric or not. The next is the pile fabrics. You look at this cut pile fabrics as a velvet absorb light and can also have greater thickness that imparts luxurious look. So, this is a typical pile fabrics. So, example of pile fabrics could be there in towels also, a type of pile fabrics, and we can also think of carpet piles are also there. Then we have stretch fabrics. Nowadays, the lycra stretch fabrics are very popular. So, the stretch is imparted during finishing. It may be inherent in the fabric type or to be added through use of stretch yarn. So, we can give this, that is we can introduce stretch yarn during the fabric production process, and therefore, we can make a fabric which is very stretchable. And transparent fabrics also sometimes are required, is it's a fabric with very low GSM, and the fibers are also very thin. So, organza, organdie are examples of semi transparent crisp fabrics. Softer fabric in this category are chiffons, georgette, crepe. These are the type of fabrics which are transparent in nature, where transparent look is something which is desirable, and therefore, we make it from very fine synthetic fibers. Three D fabrics if we go by dimension wise, as said, woven, knitted, braided and non-woven all are, we can have 3D fabrics, we can produce them using these technologies, that is woven fabric manufacturing technology or knitted or braided or non-woven. And in this case, warp and weft yarns are bound together by a series of binder yarns. So, you may have been taught in fabric production course the way we produce 3D woven fabrics or knitted 3D fabrics, like spacer fabrics is an example of 3D knitted fabrics. Comparison between 3D and 2D, absence of interlacing between warp and weft allows 3D fabrics to bend and internally shear easily without in plane buckling. That is the very important point here, and presence of Z direction thread makes a dramatic improvement in the transverse strength and impact strength also. That is what we get in 3D fabrics. 2D fabric could be very strong in the XY plane, but when it goes to Z directions, if we have a layer of 2D fabrics and make it thicker, then strength in Z direction is not going to be very good, and therefore, we need to produce a 3D structure where we have yarns also running in the Z directions. Other than x and y, we should also have yarn in the Z direction, then the fabric as a whole will also have lot of strength in the transverse directions. And as a result, what happens? They are less prone to delaminations as is found in layered 2D fabric structure. So, if we make a sandwich structure of 2D fabrics, like one after the other I place them and make a thick structures, let us say there are 10 fabrics, 2D fabrics, place one on the top of the other and I make a thicker structure. The problem is how to join 10 layers, and whatever techniques that we can use to join the 10 layers, there is a chance of delaminations, and that is one of the greatest weakness. So, the fabrics, there is a lamination problem, they easily delaminate whenever some forces acts on it, some impact energy acts on it, that is a problem, and therefore, we are going for actual real 3D structures, not by sandwiching several 2D fabrics. This gives you a little bit of comparisons of the different types of structures, 3D woven structure, 3D knitted structures, 3D braided structures and 3D stitched fabrics. Woven structure 3D, complex near net shape of preforms, properties can be tailored for specific applications. 3D knitted structures are better for mobility. 3D braided structure, complex shapes can be produced also if you have a 3D braiding machine. And the other thing is composite with complex geometry is less expensive to produce. So, 3D structures we can produce a lot of composites nowadays. When you go for making composite fabrics, 3D open structures can be used. They have a better delamination property. So, that means the layers will not separate from each other easily. Higher interlaminar fracture toughness is there. 3D knitted can produce near net shape preform, sandwich composites have lower specific density. Some structures have higher impact damage tolerance and energy absorptions. 3D knitted structure also are available nowadays. We can make on warp knitting machines 3D structures. Similarly, we have 3D braided structure also. So, different types of production techniques and therefore, the type of structure that is produced all are basically 3D structures, but the properties of these structures are different depending upon which particular type of production technique has been used to produce them. Some 3D fabrics, some images are shown here. You can see this is a spacer fabric. So, these vertical yarns are basically we call them spacer yarns. So, there are specific application of such kind of fabrics also. You see beautiful 3D fabrics here, and there are holes here. So, you can create some very complex structures for different types of end use. From there we go to the compound fabrics now. Now, here compound fabrics means it is a combination of two types of fabrics made from two different technologies. Basic fabric structure can be combined in different ways to produce compound fabrics. Quilted fabrics, one example. We can have tufted fabrics, flocked fabrics, coated fabrics, laminated fabrics, all are basically different types of compound fabrics. In the quilted fabrics, what it is there? There are two sheets, and in between the sheets you have lot of fibers, loose fibers which are there, and then we stitch them and produce what is quilted fabrics. And quilted fabrics are used as comforters or other applications are there, and in let us say for extreme cold weather garments, if you want to produce, we have to go for quilted type of fabric there, so that we can create a lot of insulation in the fabric. So, there are different types of techniques which are there to produce quilted fabrics. So, here there is a fibers are flocking on a typical surface of the fabrics which could be woven, and then here there are vertically laid fibers, and we get a fabric which is called flat fabrics. So, velvet fabrics which we find is typically an example of flocked fabrics. So, here the descriptions are given about these types of fabrics. Quilted fabric consists of a filler material sandwiched between two fabrics. Tufted fabrics which have a yarn pile inserted into backing fabric. Flocked fabrics which are flock attached to base fabric usually by an adhesive. Coated fabrics which have had a layer or layers of coating applied, and then comes laminated fabrics. So, there is so many types of fabrics are there which can be used. Now, we come to the non-open fabrics also. This is another technology to produce a 2-dimensional sheet or a 3-dimensional sheet depending upon the type of thickness or GSM we require. So, non-open fabrics, these are the production techniques: dry laid, wet laid, spun bonded, melt blown and electrospun. These are the 1, 2, 3, 4, 5 different types of non-open fabrics depending upon what kind of technology is used to produce them. Generally, in the fabric manufacturing courses, this will be taught in more details. We need to know we should have some simple a general idea, especially the characteristics of these fabrics and what are the possible use as of now. So, that if this understanding is there, it is going to help us whenever we want to choose a certain type of fabric. The question comes to our mind that I have to choose a fabric, then these are the various alternatives that will be there in front of us, and with lot of brainstorming we can decide which type of fabric we should choose. Now, let us say dry laid fabrics, carding or aerodynamically it can be produced. fiber orientation in either machine direction or crosswise or randomly oriented, that is the characteristics. And the bonding is done through needle punch. So, there are needles which are punched, or it can be hydro entangled also, or it could be stitch bonding is possible, thermal bonding is possible, and chemical bonding by resin is also possible, because the fibers are in loose to start with. Now, how to hold the fibers together, so that fabric has got certain strength, and these are the various ways to create bonds between the fibers as they lie within the fabric. And uses interlinings, coated fabrics, backing, carpet components, wipes, like that. And the other one is wet laid. In the wet laid, it is made generally from very short fibers, 6 millimeter fibers. It is used for making paper makers felt generally. So, high uniformity and random arrangement of fibers that we get here, made from wood pulp, natural fibers, polyester, nylon, glass, all sort of fibers can be used and wet laid. And the use is laminating, coating, base fabric, filters, insulation, roofing. There are so many types of use of wet laid fabrics. If you read some books where these fabrics, details about these fabrics are stated, production techniques, the properties, their end use, these details will be available in some textbooks. And then comes spun laid, melt blown, electrospun, so many different techniques are there. And whatever techniques that is used, it gives us a fabric which are all non-woven in a way, but the characteristics are different, the properties therefore become different. Spun laid or spun bonded, orientation of fibers can be varied, higher strength and tear resistance that we get. Fibers that can be used are polyester, nylon, polyethylene. So, we need only thermoplastic fibers for this. There is no need of additional resin to hold the fibers together. Melt blown, the wave consists of very fine filaments having diameter 1 to 4 micron. So, melt blown, this type of non-opens, if we want very low GSM non-opens, very thin GSM non-opens, melt blown is the way. Sometimes we need GSM of just 50, 40, 30 GSM I need, but we have to make from very fine fibers. So, melt blown non-woven is the answer for that. For most of the face mask, the fabric layer which is inside is made from melt blown techniques. We have very fine fibers and we have a very thin fabrics. So, when this combination is required, I need a very thin low GSM fabrics, but I need very small pore size, in micron level pore size are required, then melt blown technique is the answer. Then we have electrospun technique also there, and we can also produce non-woven following electrospun techniques. With this, this particular lecture is over now. So, what we have discussed, different types of fabrics that are available with us, their general characteristics, and if we know that these are the various types of fabrics which are there and these are the general characteristics, then again is going to help us to decide, to choose for a given applications. With this, we close this session. Thank you.